In the previous titration tutorial, we learned about some of the theory that goes along with understanding how titrations work and how to go about carrying out a titration. In this tutorial, we're going to focus on what you do with the data once you have gathered it, so how you go about calculating the unknown concentration or whatever aspect you are asked for once you have actually carried out the titration. And so first we'll identify some of the key pieces of information. So we see that the sample being titrated is 15 mils of hydrochloric acid, and it's being titrated with calcium hydroxide. For the calcium hydroxide, we add 49.62 mils, and there's the concentration. And so we're asked to find out what the concentration of that hydrochloric acid sample is. One of the things that becomes important here, first of all, like always with a stoichiometry question, is the equation. Okay, and one thing to note about this is that the acid and the base are in a 2-to-1 ratio, and so it's important to have that balanced chemical equation, because that 2-to-1 ratio will become important when we apply the mole ratio to figure out the number of moles of hydrochloric acid. So here I've recorded my given information and the thing I'm looking for the hydrochloric acid, and I have my given information for the calcium hydroxide, and just note that the two values that are given in milliliters are converted to liters with the same number of significant digits being held. And my plan is I'm going to take this concentration of calcium hydroxide and use the volume of it to figure out the number of moles of calcium hydroxide that were added to my sample of hydrochloric acid. Once I know the number of moles and incorporate the mole ratio, I can get the number of moles of hydrochloric acid. And once I know the number of moles of hydrochloric acid that are in that Erlenmeyer flask, I can use the volume of the sample, which we were told was 15 milliliters, and from that figure out the concentration of hydrochloric acid, or the sample of hydrochloric acid that is in that flask. And so I will just go about carrying out those few steps here. So I get the number of moles of calcium hydroxide, and notice that my liters cancel out and I'm left with moles, and then I'm going to use the mole ratio to find the number of moles of hydrochloric acid. And so here I've got, I maybe did this mole ratio just slightly differently from the other ways that I've done it. I still have the thing that I'm trying to find in the numerator. Not that it absolutely has to be, but it's easiest that way. But rather than putting this piece of information, so the other piece of information that was given in the equation underneath it, I just kept both pieces of information related to hydrochloric acid on this side, and both pieces of information related to calcium hydroxide on this side. Again, in the end, it really makes no difference, as long as when you are setting up your ratio, that the information from the equation is either both on the same side up and down, or both on, let's say, on the bottom part, or alternatively you could put both pieces on the top. But I've got for every 1 mole of calcium hydroxide, I need 2 moles of hydrochloric acid. So if I have 7.443 times 10 to the minus 5 moles of calcium hydroxide, how many moles of hydrochloric acid will be in that flask? We solve the ratio and we get this value, which is double, and that makes sense given the fact that our equation told us that for every 1 mole of calcium hydroxide we have, we would have 2 moles of hydrochloric acid in the beaker. So we have this many moles of calcium hydroxide that were used, so I have twice the number of moles of hydrochloric acid that were contained in the flask. I use this number of moles then to determine my concentration of hydrochloric acid, which is right here. And we see that, okay, you know what, this makes sense. So the concentration of hydrochloric acid is it's a reasonable value. It's in a reasonable range. The one thing here, there's not a definitive check that can be done because of the fact that we have the way the concentrations are set up, and that we have that 2-to-1 ratio. And so I could make my check into a whole paragraph long explaining things, but that's not the point of the check. The check is just that, a quick check to make sure that your answer is reasonable. Sometimes there will be definitive things that you can say or that you can use as checks, and other times it's more, yes, this answer makes sense, it's in kind of the same range as the rest of the values that are given in the question. So hopefully we see here that this is, in looking at this one type of titration problem, we see that it's really a solution stoichiometry problem, just like all the other solution stoichiometry problems that we have looked at. And as long as you apply those strategies, taking your given information and eventually finding the number of moles and then converting that to whatever you need to convert it to, you'll arrive at the correct answer.